our third day, grade 11s, of our unit exponential functions. And we're going to be solving some simple, fairly simple exponential equations. So the samples that I have in front of you take right off from where we left yesterday, where, for instance, if I have 5x equals 5 squared, and I have an equation with equal bases, the exponents must be equal. So for the first one, it's as simple as x equals 2. For the one directly below it, we have 2 to the x equals 4 to the x plus 1. They have different bases, so it's harder to draw conclusions unless you can rewrite them with the same base. So I'm going to replace that 4 with 2 squared. And then I still have the exponent x plus 1. Now that I have the same bases and I have rules for the right-hand side, power of a power, I know that I would multiply those exponents. So 2 to the 2x plus 2. I have an equality with the same bases, so the exponents must be equal. So x equals 2x plus 2. And that you can solve. I want to get all the letters on one side, all the numbers on the other. So I'm going to subtract x from both sides. I'm going to subtract 2 from both sides, and I have my answer, x equals negative 2. 7 to the x plus 4 equals 7 to the 2x. Since the bases are the same, then the exponents must be the same. So I can say that x plus 4 equals 2x. I can subtract x from both sides, and I have my answer. The one underneath that has different bases. I cannot replace, let's get the right color here, I cannot replace the 8 as a power of 2, but I could replace both of them. Sorry, did I say that wrong? I cannot replace the 8 as a power of 4, but I can replace both of them as powers of 2. So the 4 I can replace as 2 squared. Okay, 2 squared to the power of x equals, I can replace that 8 as 2 cubed. Notice that I put that number in brackets entirely. That makes me very careful with my rules of exponents. And, for instance, on the right side, I would multiply my exponents. That would make me careful that it would be 3x plus 9. It's distributive law when I multiply. On the left side, power of a power, I also multiply 2x. Now that I have an equation with equal bases, the exponents must be equal. So I can say that 2x equals 3x plus 9. And then I can solve. I am going to subtract 3x from both sides. Divide both sides by negative 1. X equals negative 9. 2 the x equals 16. I believe we did this one yesterday, but I can't make any conclusions about that unless I can write or think of both sides with the same base. 2 to the power of 4 is 16, so I can say that x is equal to 4. The next ones are hardest. I have 9 to the 2x minus 5 equals 27 to the x plus 6. I cannot rewrite 27 as a power of 9, but I can rewrite both of them as powers of 3. So 3 squared, I'm replacing my 9, and notice I put it in brackets. The exponent is 2x minus 5. Right side, I'm going to replace my 27 with 3 cubed. Exponent was x plus 6. So now I have the same base. I have power of a power on both sides. Don't forget that means you have the distributive law, and that can be a problem. Okay. Next line, 3 to the 4x minus 10 equals 3 to the 3x plus 18. I have an equation with equal bases, therefore the exponents must be equal. And we can solve that. I'm going to subtract 3x from both sides. I'm doing these quickly because you're very good at solving. And I'm not writing all the little steps, and I'm hoping that you're following quickly. Then I'm going to add 10 to both sides. X equals 28. Okay, we're going to take it up a little bit. This is really, really ugly. But we need to remember our rules of powers. If I have 3 to the x plus 2, I know going backwards that 3 to the x plus 2 would be the same as 3 to the x times 3 squared, because our rule is to keep the base and add the exponents. So I'm going to take that original expression and rewrite it as 3 to the x times 3 squared. So that's all I've done so far. Notice on the left side we have a common factor of 3 to the x. So I'm going to take out that common factor, greatest common factor, of 3 to the x. The first one is multiplied by 3 squared. The second one, there's just one of them, so I need to write that 1. I can tidy up my left side. 3 squared minus 1 is 8. Divide both sides by 8. 3 to the x equals 27. Now that's something we can work with. 3 cubed is 27. Our answer is x equals 3. I wanted to leave you a model in your notes so that you would have something to work with. Let's try a couple. 2 to the 2x minus 20 times 2 to the x plus 64 equals 0. I know that 2 to the 2x is the same as, okay, so that I'm multiplying 2 times x, so that must be power of a power. So that must be the same as 2 to the x squared. So I'm going to replace this as 2 to the x squared minus 20 times 2 to the x plus 64 equals 0. Now that looks pretty hideous, but it is something you've seen before. I'm going to replace 2 to the x, and you don't have to do this at all. I'm just going to replace it with a letter, like, let's make it a. If I rewrite this as a squared minus 20a plus 64, you know that you have a quadratic expression, and you know how to factor that. It's a simple trinomial. Again, simple in loose quotes. And we have an a at the beginning of both brackets. At the back half, I want two numbers that multiply to 64 and add to negative 20. My numbers are negative 16 and negative 4. So really, what I have is 2 to the x minus 16. 2 to the x minus 4, because that's what a is. I just didn't like the look of it. And I know when solving that if I have two things being multiplied to give me 0, that's how we got our x-intercepts before, then either one of the brackets is equal to 0, or 2 to the x minus 4 equals 0. Let's solve the first one. If 2 to the x minus 16 equals 0, 2 to the x equals 16, and I have an answer of x equals 4. If 2 to the x minus 4 equals 0, I add 4 to both sides, then my x must be 2. So I have two possible answers to this question. X equals 4 or x equals 2. Don't panic, you're going to get it. 5 to the 2x minus 625, 5x plus 625 equals 0. The first one is the same thing as power of a power. So just like a quadratic, I have something squared minus 626 times something plus 625 equals 0. So that would be the same as considering it as a squared minus 626a plus 625 equals 0. And if it helps you to write it like that, go for it. Two sets of brackets, we know how to factor this, a and a. So if I am factoring this thing, simple trinomial, I'm going to have 5 to the x. Okay, I need two numbers that multiply to positive 625 and add to negative 626. So negative 625, I say so a lot, minus 1. Let's solve these two. So either this is true, the first bracket is 0, or the second bracket is 0. I am going to add 625 to both sides. It just happens to be that 625 is 5 to the power of 4. 25 times 25, I'm just checking my numbers. So x is 4 is one of our answers. The other possible answer, I'm going to add 1 to both sides. 5 to the what is 1, 0. So x equals 0 is another solution to our problem. Another exponential equation that looks like a quadratic. 2 to the 2x minus 7 times 2 to the x minus 8. Okay, 2 to the 2x is the same as 2 to the x squared, because I would multiply those exponents and get what I started with on line 1. Minus 7 times 2 to the x minus 8 equals 0. Something squared minus 7 times something minus 8 equals 0 is a simple trinomial. I have 2 to the x at the beginning. I need two numbers that multiply to negative 8 and add to negative 7. It would be negative 8 and 1. Let's solve. I have two things being multiplied to give me a 0. That means either this one is 0. So then, it's better than my so all the time. Or 2 to the x plus 1 equals 0. Let's look at the first one. If I add 8 to both sides, I know that 8 can be rewritten as 2 cubed, so x equals 3 is one of my solutions. The other solution, I am going to subtract 1 from both sides. Is it ever possible for 2 to the x to be equal to negative 1? No. So there is not a solution here, but there is one solution, x equals 3. I have one more for you, and I have typed it on your sheet just because it's a little bit complicated. If you have 10 to the x plus 3, you can rewrite 10 to the x plus 3 as 10 to the x times 10 cubed, because our rule would be keep the base, add the exponents. The same with 10 to the x plus 4. That would be 10 to the x equals 10 to the x times 10 to the 4. So we have a common factor for those two expressions. 10 to the x times 10 to the 3 gives you the first one. 10 to the x times 10 to the 4 gives you the second one. I've got my greatest common factor and a number in the bracket. I can tidy that up. And I'm going to divide both sides by 11,000. I'm going to have 10 to the x equals 11 over 11,000, which is 1 over 1,000. I can rewrite 1 over 1,000 as a negative exponent, because 10 to the negative 3 means flip and cube. It would be 1 over 1,000. My answer is x equals negative 3.